Hello student, today we are going to discuss here some relevant problem of capacitor. So here a circuit is given and a capacitor is here. So we have to find the charge at time t. So this is a capacitor. Suppose capacitor achieved the plus q charge after time t. So we know q is equal to q naught q maximum 1 raised to power e raised to power t by tau. This is the charge at a time t. This is the equation of capacitor. Capacitor for charge. So by the Thevenin theorem, we can sort out the circuit like this, and the capacitor, this is terminal A and B. This would be like this, and all the sources, that is voltage source, would be shorted here. So shorted the voltage source, so we have to find the resistance across AB. So RAB would be, these two resistors are parallel and this is series, so this becomes 3R by 2. So on steady state, this capacitor behaves as a open circuit, so no current flows in this branch. So R and R in series, so voltage distributed here, so voltage across AB would be RB by 2. This is voltage across C. So we can write here Q at time t would be CB by 2, Q maximum is CB by 2, and 1 minus e raised to power minus 2t by 3 RC. R equivalent is 3R by 2. So this result is easily getting by using the Thevenin theorem, and the Kirchhoff current distribution. By Kirchhoff current distribution, we also find the charge at time t. So suppose here I current is flowing and this current is distributing I1 and I2, and we can write here, suppose at that instant the potential at that point A is x, and here on capacitor the potential will be q by c, and here the potential is V, here potential is 0, here also 0. So we can write here x minus V current, we writing here current. So summation of current is 0 at any point. So we write here x minus V. Here the voltage is x, here the voltage is V, x minus V upon R, that is the current in this branch, and plus summation of current is 0 plus x minus 0 upon R plus x minus q by c upon R, that is 0. So this becomes 3x minus V is equal to q by c. So x becomes q by c plus V upon 3, V plus q by c. So we can write here current I2 would be dq by dt, and dq would be, current would be x minus q by c upon R, x minus q by c upon r. Also write x minus q by c, the potential, upon resistance. This is the resistance R. So x minus qc by R. So put the value here. So dq by dt becomes, the value of x is q by c plus v, this is v, plus v by 3 minus q by c upon R. So this becomes dq by dt cv plus q minus 3q by 3rc. So this becomes dq by cv minus 2q upon 1 by 3rc and dt. Integrate 0 to q, 0 to t. So this becomes natural log cv minus 2q upon minus 2. This becomes t by 3rt, 3rc. So we put the limit q and 0. So this becomes natural log cv minus 2q upon q is 0. So this becomes cv minus sign shift here minus 2t 3rc. So we can write here 1 minus 2q by cv is equal to e raised to power minus 2t by 3rc. So it's become q is equal to cv by 2 1 minus e raised to power 2t by 3rc. So in capacitor, the capacitor never charge 100% for time constant, that is RC. If time constant, that is RC, is 5 times RC, 5 times, then capacitor would be 99.3% charge. So for the condition, the time constant is RC, capacitor only charge 63%. So we approach the next problem. Here we have to understood the problem. In this problem we have discussed here, the initially the charge on the capacitor was 0 at time t is equal to 0. But in this problem, the question says the circuit is at steady state before the switch open at t is equal to 0. That means the capacitor has initially charge at t is equal to 0, and thereafter this capacitor discharging and further charging, further becomes in charging mode. So at that particular position, that is time t, we have to find the current in this branch, that is 60 kilo ohm resistance. So we have to find the current at that particular point. So we can write here, for charge at a time t, charge on capacitor at a time t, that would be charge on capacitor time tends to 0, time tends to 0, and there is a discharging. So we write 1 minus t by RC, 1 minus t by RC. Here R is R equivalent into C, and plus here the discharging. So maximum charge on capacitor at this would be t tends to infinite. This is the condition of steady state. So when the time tends to infinite, this is maximum charge. One we can write here 1 plus 1 minus e raised to power minus ty r equivalent c. This is RC. So this is the equation. This is in this mode discharging is here. In this mode charging is here. So at the time t we have conclude both scenario. In first scenario the discharging of the capacitor, and second scenario the charging of the capacitor. So here the capacitor at t is equal to 0 having already charged. That charge is 6 cross 2. Initially it has 12 coulomb microcoulomb charge. So we have right here the potential at time t, that is potential at time infinity e raised to power minus ty. This is potential at time 0, t is equal to 0, e raised to power ty r c equivalent plus potential at time infinity 1 minus e raised to power minus ty r equivalent c. So by Thevenin theorem we can calculate here the equivalent resistance. So we know all the voltage source would be sorted here. So this is sorted here. So the redraw circuit, this 60, this 60, this 30, and we have to calculate this is AB terminal across AB, and this is also sorted, this is also sorted. So this becomes like this. So this is 30 kilo ohm, this is 60 kilo ohm, this is 60 kilo ohm. So R equivalent, arc across AB would be, so current start here, this and this are in parallel. So 60 and 60 become 30, and 30 and 30 becomes 60 kilo ohm. So this is the equivalent resistance. So we find RC, R equivalent C. So this becomes 120 kilo, 120 into 10 raised to power 3. This is in kilo, and this is 2 microfarad is minus 6. So this becomes 120 millisecond. So here also given 120 millisecond. We have to find the values here, this value and this value. So this is 120 millisecond is the time constant. So we getted it, and we have to write here the potential at time is t equal to 0. For time t is equal to 0, starting time t is equal to 0, so potential would be across the capacitor, that is 6 volt. This is parallel to this capacitor, so potential would be 6 volt. So potential at 0, time is 0, is 6 volt, and potential at infinity, potential at steady state. So in a steady state we know the capacitor would be open circuit. So this circuit becomes open, so no current in this circuit, so I have only current flow in this circuit. So this and this, these both are in series, and because of the resistance of both resistor are same, so voltage equally distributed across the resistor. So 4 volt here, 4 volt here. So the 4 volt voltage is across this resistor, so same voltage would be across the capacitor. So V infinity would be 4 volt, and we have to find the t is equal to t at any time t. Voltage at any time t, we have to find here. So let us consider here, suppose here is the x volt and here is the across the capacitor the V voltage here. So 8 we can write here upper plate voltage here 8 volt and 0 lower plate 0 0 and we apply here Kirchhoff's current distribution. So we can write here x minus 8 upon 60 plus x minus 0 upon 60 plus x minus v upon 30 is equal to 0. So this becomes x and this becomes 2 times and 2 times 60. So sigma 2x x 4x minus 2v minus 8 is equal to 0. So 4x minus 2v, this can be write as 2x minus v is equal to 8. So v becomes 2x minus 8. We have to find x because of we have to write the current equation here. Agar we have find x voltage at that particular position, then we find the current. So v is equal to 2x minus 8. So these are the values here. So we can write the values here. So Vt would be Vt voltage at time t would be 2x minus 8. This would be at t time is equal to 0, then this is 6 volt and this becomes e raised to power minus t by 120 millisecond plus this would be v infinity at time v infinity 4 1 minus e raised to power t minus 120 millisecond. So we have find here x. So 4 and 4 and 8 divide by 2. So this becomes 2x minus, this is not 8, this is 2x minus v is equal to 4. This is 4. This is 4. So 2x minus 4. 2x minus 4, it means it becomes 448 and this becomes plus 2 minus 4 and 6 plus 2 e raised to power minus t by 120 millisecond. So x would be by 2. So this becomes 4 and this becomes e raised to power minus t by x is equal to the voltage here x be written as v is equal to IR. So x would be 16 into I. We have to find I. So I becomes 4 by 60. This is in coulomb. So we have to write the final current is micro ohm. So 10 raised to power 3 here and for micro this would be 10 raised to power 6 multiplied over. So 10 raised to power 3 get we here and 10 raised to power 3 here upon 60 e raised to power minus t by 120 micro millisecond. This would be in micro ampere. So we solve it here. So we get the answer. So this becomes 66.7 plus 16.7 e raised to power minus t by 120 microsecond in mu microampere. This is the current at time t. So we discuss here another problem regarding discharging of capacitor. So we take here a case in this scenario. We either we take a spherical concentric cylinder or a concentric sphere. So in both case, suppose this is a concentric cylinder and this is a concentric sphere. Here we have to given this is radius A and this is radius B, and in between the region a dielectric material is filled, that is K, and resistivity of the dielectric material is rho. Here also the same scenario for concentric sphere, and the radius is A and radius is B, and K is the dielectric and resistivity is rho. So we have to find this capacitor, both capacitor is leaking start. So here the case of discharging, these both capacitor are leaking. So we have to find the when thereafter when the initial phase the charge q is provided and outer phase is earthed. Initial phase charge is provided plus q and outer is earthing done. So we know at outer phase the potential would be 0, so negative charge would be induced. Potential will be 0, so negative charge will be induced. So plus q charge and negative q charge. So this act as a capacitor, behaves as a capacitor. So we have to find the charge when charge becomes half from initial. This is e raised to power minus t by RC. So we have to find RC for both scenario. For first scenario, RC would be integration of R, resistance. This will be, we take a step of dr distance. So dr and area of the, suppose this is length is L. So the area become 2 pi RL. This is the area, and limit would be A to B, and capacitance we know for cylindrical spherical cell, the capacitance is 2 pi R L upon natural log B by A. On solving, this becomes rho dr and pi 2 pi cancel out, 2 pi cancel out, and this becomes natural log B by A, and LL also cancel out, B by A. And here also a term epsilon naught and epsilon R. So this becomes, and RR cancel out, sorry, 2 pi RL, 2 pi epsilon naught epsilon R into L upon natural log B by A. So natural log B by A cancel out, and this becomes epsilon naught epsilon r. So RC becomes rho epsilon naught epsilon r. Similarly, for the spherical capacitor, we can solve RC, give the same result like as the resistance rho dr by area of the sphere 4 pi r square, and capacitance will be 4 pi epsilon naught epsilon r into AB upon B minus A. So by integrating r square a to b, we find 4 pi cancel out. 1 upon r square would be rho epsilon naught epsilon r, and the integration would be 1 upon minus 1 upon r, and integration would be limit would be b to a, and we know ab upon b minus a. This putting this the values b minus a, this becomes here under b minus a upon ab, this becomes b minus a upon ab, this becomes b minus a upon ab. So this term cancel out, so this gives same results here. So we have to find here, the, so put the value here q by 2, so this becomes 1 by 2 is equal to e raised to power minus, and constant, this is rho epsilon r epsilon not epsilon r. So taking log 2 becomes log 1 by 2, we writing log 2, so this becomes e raised to power, sorry, log 2 becomes, so this becomes positive, log 1 by 2 inverse, so t rho e epsilon naught epsilon r. So t becomes, time becomes log 2 rho epsilon r epsilon naught epsilon r, natural log 2. So value of natural log is 0.69, and epsilon naught epsilon r, this is the time, and rho, this is rho. So this is the answer. So at that time, after the capacitor would be half charge leakage after that time. So another problem, in this problem, a dielectric is pulling by a solid cylinder, and the mass of solid cylinder and dielectric material are same. So in this problem, suppose here this is a capacitor, and this is also a capacitor plate, and a dielectric here. Suppose this is the dielectric, this is dielectric material here, this is dielectric here, and this dielectric having mass m, and this is attached with a string, and this is a this is a this is a solid cylinder here, this is a solid cylinder placed in a rough surface, here friction is present, rough surface, and this is pulled, and this is the, suppose this is a, this is a square, this is a square, this is a square plate capacitor, this length is a, this length is also a, this length is a, this length is also a, so this is a square capacitor. So we know, let this distance is x and this distance would be a minus x. So in this scenario, a battery is connected here, that is 3 volt, V naught say. So this is positive charge, this is negative charge. In this question, the question here, a force, tangential force, that is 1 Newton is applied, tangential force, that is 1 Newton is applied. We have to find here the current versus time graph. Current in this scenario, the current flowing from this here, and current versus time graph is linear, and we have to find the slope of current versus time. This linear graph is there, and we have to find the slope of the current versus time graph. So in this problem, when we understood here, this is the capacitor, this is capacitor, dielectric is inserting, when the dielectric is inserted in a capacitor, the at the this suppose this is positive plate, so positive charge here on the plate, and here the negative charge on the plate. So electric field from positive to negative, from positive to negative, this is external electric field. But inside the dielectric, the tiny dipole induced here, like as this minus charge plus charge, minus charge plus charge, and minus charge plus charge, and plus charge minus charge. So continuously over here, continuously. So this creates a opposing electric field here. So this electric field, direction of electric field is like this electric field direction is like this. So this reduces the effect of electric field. By the induced electric field, the net effect of the external effective field, so the potential also decreases. That is why the capacitance increases. That is why the capacitance increases on insertion of a dielectric within the capacitor plate. So here, as the edges of the plate, the electric field lines are bulged. Here electric field lines bulge. So fringing effect is here. Due to fringing effect, a inward pulling force is acted. The horizontal component of this electrostatic field, this is bulge at the edges, provide a horizontal component, provides a pulling force inside this direction. So this inserted the pull the dielectric inside this region. When this is electrostatic force, and by this force the dielectric is inserted in this region, and its accelerate velocity increasing, the dielectric, it accelerates, and due to inertia, when the dielectric reaches here, it does not stop, is over this over jump from here some distance due to inertia, and when it reaches at that fully dielectric fully inserted in the region of the capacitor, this force becomes zero, this horizontal force becomes zero. Thereafter, when this reaches here, thereafter the fringes here, the fringing effect, the pulling force applied in that direction. So the movement is here, thereafter movement is here. So he oscillates. So here the electrical energy of the capacitor change in kinetic energy of the slab. this is the slab inserted, this is dielectric slab. So energy converted in electrical energy converted in the dielectric energy of the, this oscillate, the this slab oscillate but not do simple harmonic motion because of the pulling force, the pulling force do not scale with, displacement. Because of the oscillation for simple harmonic motion, the force would be proportional to x displacement. This is displacement. For oscillation, force is inversely proportional to x power n. This is means ki, this is means the x raised power 2, 5 or integer or non-integer, this is complex. So SHM do the sinusoidal wave formation, this is curved or complex path, this sinusoidal or cosine path, but this oscillation is oscillate only. So we have also the calculate the time period of oscillation by the getting the acceleration, and getting the in respect to time, and time period would be 40. So putting the value of t and getting the answer. So in this problem, this is the concept I discuss here, but in this problem we have to find, in this problem we have to find the slope of the current versus time graph. So we know here the force is acting, so we calculate here the equivalent force. So here capacitor, this is in this region air, and this in this region is dielectric K. So dielectric K, in this region, dielectric K is present here, and we can write here the this region, in this region there is air, and in this region is dielectric. For this region, this is length x, and the area is A, the width is A. So x and A will be the area of the this region capacitor, and this region capacitor area would be A minus x into A for this region. So these two, this is air and this is dielectric, these two, this dielectric and this capacitor are in parallel because of the end are connected with this equipotential surface. This is equipotential surface. So these two are parallel. So we write the C, we find the C equivalent. C equivalent would be C1 plus C2. So C1 here, C1 would be epsilon naught A, this would be A into x upon D. D is the distance between the plate. So we can easily write here the equivalent capacitance. So equivalent capacitance would be, so this distance is D, and here we show the electrostatic force is externally downward. This phenomena is over here explained. So we write the C equivalent, this would be, so this becomes epsilon naught into area, epsilon naught A, x into A by D. This is for this plate, and this is epsilon naught K A minus x by D. This is the equivalent capacitance, and we know force is equal to electrostatic force is minus du by dx. So on differentiate these terms, we get x would be cancel out. So this becomes epsilon naught A by D K minus A and internal energy is half Cv square. So this becomes V 2D and this becomes V naught square. And in this problem, we have given a value that is A epsilon naught A K minus 1 upon D. Epsilon naught A K minus 1 upon D, this is 1 by 9. This value is given. So putting the value, we directly differentiate. First we write the potential energy, this is half Ce V naught square, and value C put and differentiation, we get this result. We direct write down here. So putting the value here, Fe would be 1 by 9, this would be 1 by 9, and the potential here is 3, so 3 square and 2, this becomes 0.5 Newton. So Fe is 0.5 Newton. So we get the value of Fe and we write here the equation for the motion. So here the tension T is acting here and tension T is acting here and the friction F is acting here, friction force, pure rolling. So we took alpha is in direction and the center of mass accelerate with A. So here the block also accelerate with A, which are attached from here, and we write the equation here. So writing equation here. So writing equation here. So we remove it and we find the value of force, that is 0.5. So this term remain here and we solve out it. So the equation of tension would be tension minus 0.5, that would be, and mass of for both the dielectric and the solid cylinder is 1.1 kg. This is given. So 0.1 A, this is acceleration, and second equation is T F plus F. F is 1 Newton, 1 plus F minus T is equal to 0.1 A. Taking torque about this point let O. So torque will be F cross R cross F for this. So we write R cross 1 minus this frictional force torque is anti-clockwise, this torque is clockwise. So this becomes R cross F is equal to half mr square is the moment of inertia of the solid cylinder. So m is 0.1, r is r square, mr square into alpha. Alpha is equal to a by r, because of here pure rolling is here. Pure rolling because of here rough surface is here, friction is acting, the friction is static friction, not kinetic. So pure rolling is here. Because of surface is on rest and pure rolling is here, we can write here alpha is equal to, this becomes alpha I into alpha, alpha is equal to a by r cancel out. So on addition of the equation, T cancel out, FF cancel out, this becomes 1.1, 1.5 and this becomes 0.2 and this becomes plus 0.05, this becomes 0.05 A. So A would be 1.5 1.25, this becomes 6 meter per second square. This is the acceleration. So we know the acceleration is here A. So we find the distance traveled, x is equal to initially the slab is at rest, the dielectric material is at rest. So this becomes half AT square. So x would be 1 by 2 into 6 into t square. So this will be 3t square. So we have to find the current here. So we know Q is equal to CV. So charge would be Q would be CV. So multiplied by V naught, CV naught. Here voltage is V naught. So CV naught would be the charge. And putting the value of x here, x is equal to 3t square. So we have to, for differentiation, for getting current, we have to change the displacement in the function of time. So this becomes 3t square and x becomes 3t square. 3t square. So by solving this, so differentiation with respect to t, I would be dq by dt. So this would be epsilon naught 6t a by d, and this becomes epsilon naught k by d. Differentiation of a is 0, or this becomes minus 6t into v naught. V naught is 3, putting the value here. So 6 common, this becomes 6t common. So this becomes into 3, this becomes, and minus sign taking out. So this becomes k minus 1 epsilon naught a by d. So this is the value epsilon naught a k minus 1 into a by d. This is 1 by 9. So this becomes 6 cross 3 by 9 into t, 3 3 2 minus 2t. So current we in this question we have to given current is proportional to time. Current is linearly proportional, but that is the equation of line. Line equation y is equal to mx plus c. Here m is the slope, so minus 2 would be the slope. So the slope of the current would be minus 2. This is the question, very good question, multi-conceptual question. So by these problems I discussed here would be very beneficiary to aid your fundamental growth, and would be very helpful for the aspirant who is preparing for NEET and JEE Advanced. So thank you and take care.